Hi, this is Dr. Nick from the ECG Academy, and this section is entitled Interventricular Conduction Disturbances. So we're going to be talking about things that slow down the electrical conduction through the ventricles. And what happens is your QRS gets wide. But before we start looking at tracings, let's review the cardiac conduction system. Remember, there's a sinus node that fires on a regular basis, and these electrical signals spread rapidly across the top chamber, giving rise to a P wave. That electrical signal then enters the AV node through transitional fibers. The AV node delays the signal slightly and then passes it down to the His-Purkinje system. So you have the main bundle of His here. You've got the bundle branches, including the right bundle branch that goes to the right side of the heart. Remember, this is the right ventricle. And you've got the left bundle branch that goes down the left side. Now, the left bundle branch splits up, and in many people, we can identify a kind of a functional half a bundle, what's known as a hemifascicle. There's an anterior one and there's a posterior one. And in the intermediate course, when we talk about hemiblocks, we'll get into more detail with that. Any disturbance in the electrical conduction through the ventricles is going to wind up making the QRS longer. Why is that? Remember that the P wave is the atrial depolarization and the QRS complex is ventricular depolarization, so the width of the QRS is a reflection of how long does it take for the electrical signal to get around to the ventricles. And when there are problems with the electrical system, branches of this bundle branch system or the Purkinje fibers that don't work, it takes a little longer. What you need to understand is that Purkinje fibers have a very rapid speed of conduction. These things conduct at literally meters per second. So that's why these fibers are well suited for interventricular conduction, because the signal zips around so rapidly that it allows a very organized synchronous contraction of the ventricle. So what happens when one of these bundles doesn't work? Well, let's say if this bundle doesn't work, then part of the ventricle here doesn't get the signal rapidly. So what happens is you get cell-to-cell connections through those gap junctions that allow the signal to get into this area, but it takes a lot longer. So the signal, for example, would have to come down this fiber and then very slowly conduct, well, relatively slowly conduct, at least compared with the rapidity of the Purkinje system. And that just takes a little bit longer. And so what happens is you get widening of the QRS complex, and that's how you diagnose an interventricular conduction disturbance. Okay, let's take some examples. Here is an ECG that's fairly normal. I placed it so that the beginning of the QRS complex happens to be on this heavy line. So if you measure back, the PR interval is 3.5 boxes. That's 140 milliseconds. The QRS duration here is 2 boxes wide. So each box, remember, is 40 milliseconds, and that gives you 80. Well, the normal QRS duration should be somewhere around 80 to 120 milliseconds. So this being 80 milliseconds, that's fine, and that really means that the electrical signal is really zipping around the ventricles and that the conduction system appears to be fine. Okay, well, what happens when you look at the QRS complex and it just looks funny? It looks weird. It's got little notches, it's got little wide parts, but when you take the total duration of the QRS complex from this heavy line to here, it's just under 120 milliseconds, maybe 110. So the duration here is normal, but it just looks like it takes a funny turn somewhere. It could be that some of these little branches here aren't working right, and the signal may have to go down one branch and then turn around, like, backing up into a steep driveway. So this is known as a nonspecific interventricular conduction delay, or nonspecific IVCD. Now, some people call it interventricular conduction disturbance. Some people call it delay. It really kind of means the same thing, that something is happening in the conduction of the electrical signal through the ventricles that makes it look a little funny. But it's still less than 120 milliseconds. So this is a common electrocardiographic diagnosis, a nonspecific IVCD. But you can see it's a little bit widened. It just looks a little funny, but it's not classic for any other particular problem. Well, we're going to talk about a number of different IVCDs in this section to introduce the different kinds of IVCDs that you may encounter, and then in the last chapter introduced the concept of a functional IVCD. And so this is Dr. Nick from the ECG Academy. Thanks for watching.